The title of this lecture this afternoon is Utterly Amazing, and you'll probably find out why it's titled that way as we continue. Well, here you have a calf drinking from its mother, and that is a very good thing, and that is how a calf grows. This is a normal, good dairy cow, and you can see that that udder is quite extended. This animal has been genetically selected to produce quite a vast quantity of milk. And a good dairy cow can produce 40 liters of milk a day, and a supersonic dairy cow can produce 80 liters of milk a day, and the world champion cow produced over 120 liters a day, and it needed to wear a special corset-type bra, or else the weight would tear this very structure off the animal, not off the animal, but the blood vessels would tear in the process. So this is not really a natural thing today anymore. But I want to deal more with the product itself, dairy products. How healthy are they? We are told by the world out there that we must have dairy in order to satisfy our calcium needs. Growing children need dairy. It's an energy-rich food, and there's no doubt about it. One can grow very rapidly on dairy. And milk, we are told, we need milk because it contains calcium, and it contains proteins, and it contains all the things that we need. We also know that there are problems with it, and that there are high concentrations of fat and cholesterol, and so some people are advised to take skim milk rather than milk. So is this true, and how good is milk really? Well, the industry has a huge marketing drive, and to compete with the dairy industry in terms of marketing is really quite something. They also have the law on their side. They seem to believe that the word milk belongs to them. And in some countries, you may not name any alternative product milk. You must name it something else. So in some countries, you may not say soy milk, for example. You must call it soy drink or whatever, because the dairy board would take you to court if you use the word milk. Well, I'm going to use some publications here to show you what the scientific world is saying of this. Of all mammals, human milk has the lowest protein content and the lowest ratio of casein to whey. Now, casein is the protein that you find in milk. And there is a huge production of milk, so if you make evaporated products, then sometimes there is a huge excess of casein in the world. And you can find casein in just about anything, any product, from cookies to baking to power drinks to you name it. You will find casein. And casein is species specific. It's a very specific feeding protein. It's a very compact protein, and it needs special circumstances for digestion. So casein, for example, needs a special enzyme which will unravel it so that it can be cleaved in the normal digestion process. And in infants or in calves, the product that will do that is called renin. And renin curdles the milk and opens up the molecule for digestion. And so animals will produce this either in the lining of the gut. You will find pigs producing this, and calves produce it. And you can use this renin as well as an extract in the cheese production because it will help to curdle the milk. So casein is pretty species specific. The amino acid composition in different species is different. But of all mammals, human milk has the lowest protein content and the lowest ratio of casein to whey. So if we're going to compare them, for example, you will find that in the human, there are 1.2 milligrams per liter of casein. That's what there is. And the time required to double the birth weight is 120 days. If you go to the horse, you'll see the horse has exactly double the amount of casein, or protein in general, 2.4 milligrams per liter, and the time to double weight is 60 days. That means exactly half. So there's a very good correlation there. A cow has 3.3 milligrams per liter, and the time to doubling birth weight is 47 days. A goat, 4.1, 19 days. A dog, 7.1 milligrams, 8 days. A cat, 9.5, 7 days. A rat, 11.8, 4.5 days. So if protein is the reason why we drink milk, then the best milk to drink is rat milk. No doubt about it. There's another problem that we have over here. We'll see that the human takes the longest to double the birth weight. Now, when a human is born, the moment the baby is born, he gets up and he walks around and says, "Where's the food?" Right? No, he doesn't do that. What does he do? He's totally helpless. And the brain is still developing. In fact, there are sutures which help it to be born, and the brain is the important structure that still has to develop. The nerves are still connecting up, and so a baby is totally incoordinate, and the nervous system has to develop after birth in a human. A human is a species where the brain is paramount. A cow is not too interested in school and calculus. It's more interested in walking around and feeding. Is that correct? And so the food type that is geared for a cow is one to make musculoskeletal development possible and is not geared for brain development. So if we feed the human cow's milk, then what we can do is we can induce fairly rapid growth, but it is musculoskeletal growth, and so the baby can get very, very large very quickly, and smaller infants are frowned upon that grow slightly slower. On the other hand, what is it that you would really want to develop properly, the brain or the musculoskeletal development? Well, it depends whether you're a child of a world boxing champion or of a, history professor or something like that, probably. But that's not the point. The point I'm making is that human milk, which has the lowest ratio of casein to whey, is geared for brain development. What does the brain consist of? High levels of proteins, or does the brain consist largely of fat? Basically, our brain is fatty tissue, and there are lots of fatty components. Around each of the nerve fibers, you have myelin sheaths, which are particular fat molecules. So brain and brain-connecting tissues or nerve tissues are largely fatty tissues, and so you need that type of development. Children that are raised on cow milk have a lower IQ on average than children that are raised on mother's milk. That's just a fact. So the protein that we find in this food is geared for the species, and if you work with animals in the zoo, you will know that you cannot just feed any milk to any animal. Normally they would die. The human is just so resilient that it can cope with just about any milk out there, and that's why we believe that cow's milk might be good for infants. In fact, the opposite is true. We should strive to use food that meet the nutrient needs of the older infant, yet avoid toxicity. Cow's milk simply does not meet this standard of quality. Journal of Pediatric Gastroenterology and Nutrition. So there are other problems with milk as well in terms of its purity. Here's the journal Pediatrics. You don't get better journals than these in terms of children. Babies who are fed whole cow's milk during the second 6 months of life may experience a 30% increase in intestinal blood loss and a significant loss of iron in their stools. Now, why should the infant bleed internally if it gets cow's milk? The answer again lies in the protein. The casein that occurs in the cow's milk is very hard to digest, which would mean that the situation inside the gut is such that it is very more acidic than normal and very irritating to the intestine, so that these young intestines actually bleed in the process and you lose iron that way. And adults have the same problem. People who have ulcers, for example, should never ever have any dairy product in their systems because of the irritating nature of the digestive process involved. Adults who consume large quantities of milk, who have high lactase activity, suffer repeated small galactose challenges, accumulation of galactocol in the lens, and a greater likelihood of developing senile cataracts, postgraduate medicine. Okay, what does that mean now? So the first problem about dairy products is the type of protein. The protein, casein, is very hard to digest. You need very special enzymes in order to do it. And mother's milk has human casein, and the baby would find that hard to digest. But the mother has nodes in the breast where bacteria are raised, which are called Bacillus bifidus, and this bacterium is injected together with the milk and helps to digest the casein. And then the infants also have small amounts of rennin. In a cow, on the other hand, the calf produces large amounts of rennin to cope with this huge influx of casein. So that's the way we deal with casein. Once a mammal in general is weaned, then it stops producing rennin, and it cannot digest casein adequately anymore. In fact, once an animal is weaned, it should never, ever, ever get milk again, and there is not a mammal in the world that will naturally drink milk after it is weaned. Not a mammal in the world, except the human being. And all of us switch off the enzymes which enable us to digest the casein adequately once we are weaned. So none of us have this. But there's another problem, and that's the sugar in milk. You see, the sugar in milk is lactose. And to digest lactose, you need an enzyme which is known as lactase. And lactase is an enzyme that occurs until you are weaned in most populations. Now, in the white population and in the generally European stock population that has lived in cold climates for many, many centuries, and where people have been raised on milk for a long, long time because that's all they had. They used to plant their grazing in the winter, in the summer, harvest it, and they would have their cows in their sheds, and that's what they would live on throughout those winters. Dairy, 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 dairy. That was the staple food of the European. And so in Europeans, the enzyme lactase continues to be produced after the weaning time, just because milk has never been withdrawn from the diet. But in most other nations where children in Africa, for example, or in Asia are nursed by mothers, and once they are weaned, that's it, lactase ceases to be produced, doesn't get produced anymore. And the enzyme lactase splits the sugar lactose into its two components. The one is glucose, and the other one is galactose. Now, galactose is one half of lactose. Now, in an infant, there's another enzyme which will change galactose to glucose so that they can use it. So there's an enzyme called beta-galactosidase which will take this galactose and change it to glucose as the baby needs it. Now, guess what happens when you're an adult? That enzyme stops being produced. Once you are weaned, you don't produce it anymore. So if you ever consume lactose as a sugar, you might still, if you are a European, have the enzyme lactase that can split the lactose into glucose and galactose, but you won't have sufficient of the enzyme or none of it as an adult to split the galactose or to change the galactose to glucose, which means that no human being actually should ever use lactose as a dietary food ever. Because what do you do with the galactose now that you don't know how to use it anymore? It now becomes a foreign substance in your body. So every time you have a glass of milk and you're converting everything that you can use in there, you will sit with galactose challenges. And what do you do with galactose? Well, you don't know what to do with it, you store it. So you store it in your skin, everywhere, including your eyes, your cornea. And so senile cataracts largely are galactose deposits which have accumulated over time. So you don't want to do that. What's wrong with dairy products? Here's the Physicians Committee for Responsible Medicine, Washington, D.C. They will tell you that dairy products contribute cholesterol and fat to one's diet. Comparing the cardiovascular status of ovo-lacto-vegetarians and vegans has proven that while both are healthier than meat eaters, vegans have a better cardiovascular status than vegetarians who consume dairy products. And these are all the journals, the Journal of American Medical Association, American Journal of Clinical Nutrition. This has been known for a long, long time. Even the Journal of Dairy Science will admit that milk has been identified as a cholesterol-elevating fat because it contains cholesterol and is primarily saturated. That's a half-truth. So I'll acknowledge that they have half the truth there. The other half is worse, which they don't mention, and we'll come to that in a moment. Iron deficiency, we've already spoken about it. Iron deficiency is more likely on a dairy-rich diet. In addition, clinical studies have shown that infants consuming cow's milk lose blood from their digestive tracts. We've dealt with that. Diabetes, this is an interesting one. Insulin-dependent diabetes, that's type 1 diabetes or childhood onset, is linked to dairy products. And this has been fairly well established over time. And I'll continue with that in a moment as to why that is the case. Ovarian cancer, as the journal Lancet, a Harvard study found that when dairy products consumption exceeds the enzyme capacity to break down galactose, there is a buildup of galactose in the blood which may affect women's ovaries and make them actually infertile. In the European countries, 1 in 4 couples seek fertility help. 1 in 4. That never happens in Africa. Did you notice that? Never happens in Africa. Now here's this cow's milk linked to diabetes. In Lancet Medical Journal in 1999, they found that new evidence published Friday adds weight to a controversial theory that feeding cow's milk to babies may cause them to develop diabetes in later life, the Lancet Medical Journal said. Already in 1978, they said, drinking cow's milk may weaken the immune function in children and lead to problems of recurring infections. A young age at introduction of dairy products and a high milk consumption during childhood may increase a child's risk of developing juvenile diabetes, the journal Diabetologia, 1994. So how come it causes diabetes? What was the theory behind that? Again, it's linked to the protein. This protein casein is very poorly digested, which means that it only breaks down into little bigger chunks. You get energy from it because parts of it are digested, but the pieces sometimes get translocated and end up in the blood as pieces. Now all of a sudden, the body recognizes an abnormal protein. And it just so happens that cow's casein has an amino acid sequence in one part of the molecule which is very similar to the amino acid sequence on the beta cells of the pancreas. So what happens is, when the body recognizes the strange protein, it makes an antibody. And that antibody, if that sequence of amino acids happens to be present in that piece that's in the blood, is an antibody to that amino acid sequence. And then that same antibody attacks your own beta cells and destroys your pancreas. And then you have diabetes type 1, and you have no more insulin-producing cells, and then you have diabetes type 1. Then the only solution is to take insulin for the rest of your life. Now, there was a lot of controversy about this because Japanese babies sometimes develop diabetes type 1, even though they never got cow's milk. They only got mother's milk. And so this idea was rejected for a long, long time, until scientists found something very exciting. They found that the Japanese babies that had diabetes type 1 were from mothers who had been subjected to the United States diet. They'd lived in America for a while, and they were using dairy. So they analyzed the mother's milk, and guess what they found in the mother's milk? Cow casein. Why? Because the mother wasn't digesting the cow casein properly. It was also translocated partially into their bloodstream. The body gets rid of it, and a gland throwing things out is a convenient place of getting rid of it. The baby was getting cow casein and making antibodies because it couldn't deal with it, and that's where diabetes 1 came from. So the theory today is pretty well confirmed. Early cow milk exposure may increase juvenile diabetes risk by 1.5 times. Early studies already showed this. Diabetes does not occur in diabetes-prone rodents reared on a diet free of cow's milk for the first 2 or 3 months of life, indicating that cow's milk protein can trigger the disease. The New England Journal of Medicine reported that in 1992 already. They've known this for years. And only now is it slowly filtering through to the medical world that this is actually the problem. Researchers from Rome and London said they studied 47 patients who had recently developed insulin-dependent diabetes and found that 51% of them had immune cells that grew and replicated when exposed to a protein called beta-casein. Comes from cows. Found in cow's milk, only 2.7% of healthy people in a control group had immune cells that reacted to the cow's milk protein. So there you have it. Casein seems to be the problem. All right, here's this other study that was done on the sugar. 5 years ago, Kramer from Harvard Medical School linked galactose, that's sugar, consumption with increased risk of ovarian cancer. To look for hints for this sugar might also affect fecundity, that is fertility if you like. His team compared published data from 36 countries on the rates of fertility, per capita milk consumption, and hypolactasia, that is low lactose, the adult inability to digest lactose. In February 1, American Journal of Epidemiology, they now report a correlation between high rates of milk consumption and waning fertility, beginning in women just 20 to 24 years old. You shouldn't become infertile at 20 and 24. You should be at your peak. The strength of that association and the rate of fertility decline grew with each successive older age group studied. In Thailand, for example, where they don't use dairy because they are lactose intolerant, when 98% of adults are hypolactasic, they're lactose intolerant, average fertility in women, 35 to 39, is only 26% lower than peak rates. So you stay fertile for a long, long time at age 25 to 29. By contrast, in Australia and the UK, where hypolactasia affects only about 5% of adults because they keep the enzyme, because they have this history of milk consumption, average fertility by 35 to 39 is 82% below peak rate. What a tremendous difference. And the difference is the dairy. The dairy is the bad news. Cataracts, as we have seen, are linked to dairy products. There are many scientific publications to show that. Lactose intolerance we'll deal with in a moment. Food allergies. Milk is one of the most common food allergies. If you have migraine, if you have asthma, we'll deal with them in a moment. The first product to look at is dairy. And that is the one that will not test positive in most cases. If you go for allergy tests, you will test positive to all the secondary allergies and seldom to the primary allergy. So this is one of the biggest problems in the world today. Toxins, like other products from animals, breast secretions contain contaminants, pesticides, drugs, and all kinds of problems, antibiotics, you name it. And we've analyzed quite a few of these over our lifetime, and I'll tell you the picture is not so hot. Lactase deficiency. That's the enzyme that breaks down the sugar lactose in milk. Now, the Danes are only 2% lactose intolerant. That means they cope with lactose. They can break it into glucose and galactose, but they don't cope with the galactose. They still have that problem. If it comes to the Finns, they're 18% lactose intolerant. If it comes to the Indians, 50%. The Israeli Jews, 58%. Peruvians, 70%. Black Americans, 70%. Ashkenazi Jews, 78%. If we go up, Arabs, 78%. Green Eskimos, 80%. Taiwanese, 85%. Greeks, 85%. Japanese, 85%. Thais, 90%. Filipinos, 90%. African blacks, some say 90%. Actually, it's more. That means they cannot tolerate lactose at all. So, in fact, only white Europeans can tolerate lactose, none of the others. In fact, African blacks are 95 to 100% lactose intolerant. The Zulu nation, almost 100% lactose intolerant. And as you go down the list, you'll see that only North American whites and white Europeans can tolerate lactose. Now, isn't it interesting that this group down here wants to dictate to the whole world up there that in order to be healthy, they must eat like them. And what happens? They all become just as sick as they are. That's what happens. So let's have a look at this lactose metabolism. We've been speaking about it. There's the sugar lactose. That's the one that you get in milk. And you break it down to glucose and galactose, and you need an enzyme which is called lactase. That enzyme switches off after weaning in every nation, and in whites, it only partially switches off. Is that clear for everyone? All right. The galactose, to break down that, you need to change it to glucose. We cannot use galactose. It's useless to us. So you need this enzyme, beta-galactosidase, and that enzyme is only produced until you're weaned, and you no longer produce it. So none of us have enough as we sit here today, and none of us can convert that adequately to that. And yet, if you look at your advertisements, they'll put the white ring around the black people, the white ring around the black people, around the white people, and even the cartoons get the white ring. Why? Because they want to induce you to drink milk. There's another American advertisement. Great for growing chicks. Got milk? Well, they should say there, great for ovarian cancer, great for infertility, great for, dumb blondes too, because it's not so good for brain development. They should put a sub-list over there. They don't put that on the advertisement. Here's a nice little cartoon that I quite like. Two little kids. The one is a black kid, and the other one is a white kid. And they've just spilt the milk. Now, is that a curse or a blessing? That is the question. Is that a curse or a blessing? Let me tell you the difference. This little white kid is going to be lactose tolerant. This little black child is going to be lactose intolerant. Okay, now, let's say they had not spilt the milk and they actually drank the milk. The little white kid would have no problem with the milk in terms of digesting the sugar because it has lactase, the enzyme, breaks it down, but it would have problems with the galactose, which would affect certain parameters. Then the casein, the protein in the milk, it would have problems with that as well, and they would tend to allergies and all kinds of things, but it could grow quite well on the casein, no problem. And then there's fat in it, which also helps to grow quickly, give cholesterol, all the bad things. So not the best thing for the little white girl. If she has this milk, because she is not lactose intolerant and because milk is fiberless, she would tend to become constipated from the milk. Constipated. The The little black boy over there, he would have the same problems except that he doesn't have lactase. And so he cannot ferment the lactose. So it passes straight through into the colon where there are bacteria which can do it. So they split it. And now suddenly he has free sugars down here in the colon, and that attracts water into the colon, and he gets diarrhea like crazy. So 2 little kids come to hospital. The one is so constipated that they sometimes use little saws to cut it apart and pull it out with tongs in babies from constipation. And this poor little kid has diarrhea like crazy, and so they'll treat them totally differently, although they both have the same reason for their demise. Osteoporosis, we'll talk about that in a moment. How important is dietary calcium in preventing osteoporosis? That's an interesting question. Here's an interesting one from the journal Pediatrics. Colic. 1 out of every 5 babies suffers from colic. Pediatricians learned long ago that cow's milk was often the reason. We now know that breastfeeding mothers can have colicky babies if the mothers are consuming cow's milk. There you go, straight from the journal Pediatrics. Osteoporosis is caused by a number of things, one of the most important things being too much dietary protein. American Journal of Clinical Nutrition. Oh, I could give you hundreds of publications on this. A high ratio of dietary animal to vegetable protein increases the rate of bone loss and the risk of fracture in postmenopausal women. And the more animal protein you consume, the worse you are. And which protein do you think would be the very worst of them all? Casein, the one in milk. Here's some interesting things about milk. Leukemia. Bovine leukemia virus. Now that's a virus in cattle, in cow milk, in cows. Bovine leukemia virus antibodies were present in 59% of newborn calves tested. That's the Canadian Journal of Comparative Medicine. Human T-cell leukemia virus can be transmitted from humans to animals. Such results suggest that a milk-borne infection being transferred from a mother to a baby is very plausible. Whether it can pass from a cow to a human is being studied. That was the Japanese Journal of Cancer in 1985 already. Iowa, a dairy state, has higher rates than the national average for human leukemia. American Journal of Epidemiology in 1980. Pennsylvania veterinarians have been able to grow bovine leukemia virus in human cells in the laboratory. In 1980, a study showed an increase in human leukemia in areas where high levels of bovine leukemia occurred. And here's something interesting. Cows infected with bovine leukemia virus had significantly greater milk production than their non-bovine leukemia virus-infected herd mates, which could mean that more BLV-tainted milk is being produced than previously estimated. Did you know that over 80% of dairy cows in your country, for example, have BLV? Because the farmer is going to select which cow, the one that produces more milk or the one that produces less milk? The one that produces more milk. Okay. The data confirm the presence of bovine leukemia virus in milk and identify the potential for lactogenic milk transmission of the virus. That's the American Journal of Veterinary Research by 1995. So there is evidence that leukemia can come from milk. What about multiple sclerosis? What a debilitating disease. The present data indicate that MS, multiple sclerosis patients, exhibit an antibody to bovine leukemia virus. Okay, so maybe you're getting more from your milk than you might assume that you got from your milk. Many of these sclerosis, these nerve diseases patients report consuming large quantities of milk. Other diseases, even the Journal of Dairy Science admits that TB, brucellosis, diphtheria, scarlet fever, Q fever, gastroenteritis are transmissible by milk products. And the Journal of American Medical Association, milk is an excellent vehicle of infection because its fat contents protects pathogens from gastric acid, and being fluid, it has a short gastric transit time. So you can get infected with milk. The big stink, listeria infections in the UK. Notice how they've been going up here since the 80s, how they have increased over time. And listeria is one that will cause, as I said, blindness, stillbirth, deformities. It's quite a wicked one. We've had quite a few outbreaks in our country. Switzerland, there have been quite a few outbreaks of this. So the fact of the matter is that dairy doesn't seem to be as good as it seems. Listeria organisms excreted in cow's milk escape pasteurization. So it doesn't even help to pasteurize them. It's interesting. We tested milk for pathogens. And we went and took raw milk and we tested retail pasteurized milk. And you find lots of lactobacteria in raw milk and very, very few, if ever, of the pathogens. Then you go to the retail milk and you find no lactobacteria. They're all dead. They've been pasteurized away. But what do you find? You find pathogens alone. They survived, and now they can grow in the milk. So these days, milk doesn't tend to go sour, but it develops a bad odor sometimes. And that's because it has pathogens which make it go rotten rather than sour. The results report the hypothesis that human listeriosis can be a foodborne disease and raise questions about the ability of pasteurization to eradicate a large inoculum of listeria from contaminated raw milk. It doesn't work. Now, I talk about this everywhere in the world. Prof's crusade against milk has them frothing. There was a newspaper article about some Walter Veith guy who was talking about milk. In fact, the dairy board came and wanted to put me in a box. And I said, would you care to sit down? And these guys are big. Dairy board farmers, they are huge. After all, that's what they've been eating all their lives, right? And I felt very intimidated. And I gave them my lecture. And at the end, they were actually begging and saying, couldn't you please keep it quiet for the sake of the industry? So I said, well, if you can take all the diseases upon your head, I would do that. So, no, there are other publications, also books, which talk a lot about this issue. Move Over Milk is one, Milk the Deadly Poison, very many interesting things. High infant death rates from cow's milk. Now, this is an interesting one. This is now in areas where we don't have industrialization. In other words, third world. Cow's milk, 84.7%, 84.7 death rate at 9 months per 1,000 infants. That's quite high. If 84.7 out of every 1,000 die, as opposed to 1.5 in these areas. Now, what about areas like the United States or Europe? Nelson's textbook on pediatrics, improved medical treatments have changed this picture, and currently the death rates are similar for breast and cow's milk formula-fed infants, except in lower socioeconomic conditions or unsanitary conditions. Even in an era of antibiotics in the USA, infants fed formulas or cow's milk are 80% more likely to develop diarrhea, 70% more likely to develop ear infections when compared to breastfed infants. How many little kids today have to get grommets constantly in their ears? The only reason why they have to get them is because of dairy. Your infectious mode is far higher if you are on dairy than if you are not. So let's just wrap up the milk-associated conditions which you find in the scientific literature. This does not come out of my thumb. This comes out of the scientific literature. Chronic fatigue. Many people speak to me about chronic fatigue. Take out the dairy, and the problem is very often solved. Tension headaches, musculoskeletal pain, hyperactivity, bedwetting, allergies and congestion. Many, many allergies can be taken straight back to dairy. Asthma and respiratory difficulties. Well, for one, my wife was an asthma sufferer. She had to take an asthma pump. She could not go anywhere without an asthma pump. She was a constant asthma sufferer. It was a nightmare. And since she threw out the dairy, she didn't have to use the asthma pump. It took about 6 months in her case. And she never needed an asthma pump again. In fact, once we had a knock on the door and an asthmatic was having a terrible asthma attack right there, and it was tough. We had to rush him to the hospital. But she had her last asthma pump, which had been lying for months in her drawer, and she gave it to him, and that helped him to get to the hospital. So asthma, very definitely involved. Early arteriosclerosis from oxidized cholesterol. Now, that's a very important point. Cholesterol itself is not so problematic. Oxidized cholesterol is problematic. And milk is in air and oxidizes very readily, and milk is one of the prime sources of oxidized cholesterol. And you would want to avoid that as much as you can. Juvenile diabetes, we've dealt with in quite some detail. Acne, all the problems associated with trying to get rid of the products you cannot digest come out through the skin. Acne, rheumatoid arthritis is often associated with dairy consumption. And all the nerve disorders like neuralgic diseases, Gerich's disease, multiple sclerosis, and IQ. There are numerous studies which show that children raised on dairy have a considerably lower IQ than children raised on mother's milk, for example. So with all this listing, why would you want to use dairy products? One reason, and one reason alone, remains. The fat is bad, the protein is indigestible or partly digestible and is bad for you. There's one reason and one reason alone why you would want to use dairy products. And what is that? Calcium. That's it. Calcium. So in our next session, we will deal with some of these issues. Right, we have been looking at dairy products in our previous sessions, and we looked at all the symptoms that you can get from dairy consumption. Known advantages of breastfeeding over milk consumption, cow's milk, is mother's antibodies are passed on to the baby. That's one important point. 2, mother's white blood cells are passed on to the baby. Breast milk contains lactoferrin, which blocks E. coli bacteria growth, so the baby has a better bacterial distribution. Breast milk is usually sterile, unlike cow's milk. And only 25% of calcium in cow's milk is absorbed by the body. So there's your first point. Yes, maybe milk contains a lot of calcium, but what good is that if the absorbability is so poor? Human milk, although containing less than half the calcium of cow's milk, is a better source of calcium because of its high absorption. So there's another reason. And anything dark green, kale, turnips, sesame seeds, are better sources for the same reason. Now, what are the disadvantages? The fat in cow's milk is not easily digested. Cow's milk is deficient in vitamin C. Cow's milk is deficient in vitamin D. And if we look at the protein content, let me remind you again that human milk has the lowest protein content compared to any of the others. And it's also low in phosphorus, whereas the cow's milk is high in phosphorus. So the ratio calcium to phosphorus in cow's milk is totally wrong for human development and human needs. Then cow's milk has been highly correlated with prostate cancer, ovarian cancer. By the way, not only prostate cancer, but prostate infections. And you know how many young people suffer from prostate infections, recurring prostate infections? Get rid of the cow's milk, and it'll be a far improved situation. Ovarian cancer, we've already looked at that. Rectal cancer, breast cancer. If you look at the correlation over there, it's dramatic. Look at countries like Denmark, Switzerland, Austria. Those are the top breast cancer countries. And countries that don't use any dairy, Thailand, Japan, Mexico, these countries have much lower incidences. And then you get some additives in your milk. You get some of the cow's lunch from yesterday. You get some bacteria that you do not want to have in there. You can get these viruses like bovine leukemia virus, which can cause leukemia. You get prions, which can cause mad cow's disease, antibiotics, hormones, organic pesticides, growth stimulants, all of those products. Bacteria in milk is limited to 20,000. Milk after pasteurization should contain no more than 20,000 bacteria per milliliter of milk and no more than 10 coliform bacteria in each milliliter. Once you've pasteurized it, the bacteria that you have are largely the bad ones and not the good ones. So, now you're saying to yourself, okay, maybe I shouldn't have my milk. But if you look at these products, how many of these products contain milk? It really is a problem now, because just about everything out there contains dairy products. And cheese. Some people say, well, I won't drink milk, but I'll have cheese. Cheese is still okay. Now let me get to my pet topic, which is cheese. Are you ready? Let's have some fun with cheese. What is cheese? It's propagated as a high-energy growth food, and it's used so widely in the world today that one can hardly imagine a life without it. Isn't that right? One can hardly imagine it. Imagine all the things that are sold out there that contain cheese, and the pizzas and the lasagnas and all these marvelous things. How's cheese made? Firstly, you take the milk, and then you add a culture, and then you have some fermentation, and then you get a curd. And you have some whey. And the curd you can use, and you can make cottage cheeses of them. These are the soft cheeses. Now, what does the curd contain? Just wrap it up for me. It contains high cholesterol oxidized fat. It contains which protein? Casein and some lactoglobulins and all of those, which are not easily digestible. And then it contains, if it's cultured and it's been fermented, then it won't have any more lactose in it. The glucose will have been fermented away and been changed to lactic acid. That's not a big problem. But the galactose will be present as what? As galactose. So what's bad in this cottage cheese? The fat is bad, the protein is bad, and the galactose is bad. Then, when you mature that further, you get soft cheeses. And if you mature that further, you get the mature cheeses, and all of that comes from this curd. Now, what has happened in a mature cheese? In a mature cheese, what has happened is that the bacteria have worked on the product, and what do the bacteria actually do? They utilize anything that's useful, because bacteria have to grow. So they utilize everything that's useful until they get to the point when they've used everything that's useful, and that which they cannot use remains. Then the process stops, and we say it has become mature. Does that make sense? Is that logical? Yes. All right. Now let me try and put this to you kindly. If you eat a meal and you've utilized everything that you can utilize, and then the process stops, what do you do with the rest? Yes, you go and sit in that special little chamber where you have this chain effort, and you go, and it's gone, right? So basically, mature cheese is bacterial, whatever. that's left over. And it even has the smell associated with it, which we have turned into something artistic and delectable. Isn't that so? The better and more aromatic, the more expensive it becomes. So we have become experts in producing this product, and we call it food for some strange reason. Now, you pop it into your stomach. The bacteria didn't have very much success with what was left over. That's why it's called a mature cheese. It's highly rich in casein. It has some oxidized fat, which is the worst thing that you could possibly have. And this casein is indigestible. The bacteria do not have the enzymes to cleave it. They don't have the acid medium. We have an enzyme, pepsin, which can actually cleave proteins, but it really battles with casein. Because you need something else to unwind it. What is that? Renin. Do we have renin as adults? Yes or no? We don't even have enough of it as infants. That's why mom adds Bacillus bifidus. No. We don't have it. So do we cleave this protein very well? Yes or no? No, we don't. And so the cheese stays in there, and we produce a very acid system, which can cause gastritis and chronic ulceritis over a long period of time if we eat a lot of it. And the amazing thing is, we occasionally send samples through for analysis. And that's when the sphincter opens and a little sample goes through. And there are receptors there which measure the size of the molecules. And if they are too large when they come through, we send a signal back and say, close up, the job's not done. The job's not done. And then it stays in there longer. Now, I've already told you that normal plant foods will be in and out of the stomach within 4 hours. Finished. If you add meat to the diet, it can stay longer. It can stay up to 6 hours. If you add cheese to this, it can stay in there for 10 hours, even longer, 12 hours. 10 hours is sort of the average for cheese. And that makes for what we call satiety, feeling satisfied. That is why if you want to shut your guests up, give them cheese. Then they don't ask you for food very quickly because they feel satisfied. Now, I have a question for you. If you go to people and you say, why don't you change to a healthier diet and eat more plant foods? What is the first thing they will say? It doesn't satisfy me. I eat and I'm hungry again. Well, actual fact, that's what you want to be. When you eat, how much do you absorb from your stomach? Nothing. When do you start absorbing? Once it's in the intestines, isn't that right? So in other words, your stomach must be empty and the food must be in the intestines when you start getting energy from the food. What's the good of eating and keeping it in your stomach? What's the point of that? That's pathetic. So satiety might mean I feel satisfied, but the longer you feel satisfied, the worse your diet is. You want it to empty out. So a good feeling of emptiness means energy. Challenge anyone who feels satisfied for a walk up a mountain. Let's see how he feels. Satisfied with all his energy in his stomach instead of going into his bloodstream. It makes no sense. In Germany, there's a saying which says, Käse schließt den Magen, which means cheese shuts off the stomach. And that's exactly what it does. In fact, cheese should never be introduced into the human stomach. Never. It has no place there. The only place for it is in that other instrument with a chain on it where you pull and go, and then it's gone. That's the best place for cheese. If we look at the acid loads in food, we've discussed this already. Notice that mature cheese will give you an acid load of 23.6 milliequivalents. That's the most acid food that you can get. And you have to neutralize that with calcium carbonate from the body. If you want to lose bone, then go for the cheese. Now, we did quite a number of experiments on this. Here are some rats. And we tested, for example, soy and casein. When you give them casein, the urinary pH is much more acidic than when you feed them soy. Then we wanted to know about the fecal calcium loss. And when you feed them casein, they lose twice as much calcium through the feces than when you feed them soy. Which simply means what? That they don't absorb the calcium, which we've already established. It goes in there, out there. So what's the good of all this good calcium in this food if you're not going to get it? And then, even when you absorb it, that which you do absorb, what happens to that? Urea production tells us that the turnover in casein, you have to get rid of far more amino acids than when you use soy, because our body prefers these amino acids. In our age, in growth, you want a slightly different mix. Total urinary calcium loss, if we fed them casein, there was a highly significant increase in calcium loss. So, yes, you absorb the calcium, but you have to urinate it out again. So really, milk is a very poor source of calcium. Here's an interesting one. Mean fecal wet mass. When we fed rats casein, that's just the protein in milk. Now, this doesn't contain the lactose, the sugar, just the protein. So this is exactly the same as the little white girl would experience. Notice that when we fed them casein, they had a very dry fecal pellet. When we fed them soy, they had a very moist fecal pellet. You see a highly significant difference over there for those who know statistics. And we can see something very interesting. This simply means what? That these rats had an eye bulging experience when they went to the toilet, and these rats had an ooh-ah experience when they went to the toilet. So there are other advantages in cutting out these dairy products. If you look at rabbits, for example, if we fed rabbits an 18% protein ration derived from soy, casein, and milk solids. Casein just being the protein. And notice when we fed them soy at 18%, they grew the slowest. If we fed them casein, they grew quite rapidly. If we fed them milk solids, they also grew rapidly. But after about 11 weeks, those that got the milk solids were the largest. Those that got the casein, the second largest, and those that got the soy grew the slowest. But they grew. Now, that's an interesting fact. So you can grow pretty well on dairy products. And Mom will say, well, look at my giant baby. Yours looks like a shrimp. Then you counter and say, but look at my baby's head. He's got brains. See? And later on in life, once he's past his maturing stage, you will see that once they go into maturity, they grow like crazy. And the vegetarians, the vegans, they become much bigger than the others. Much bigger. My kids grew up vegetarian, vegan. They were mocked when they were small. Nobody mocks them now. They go like that through a door. And my youngest son is twice as broad as me, which is very disconcerting. I can't sort him out anymore. Here is urinary calcium loss of rabbits fed 18% protein. And you can see again, on soy, they lose the less calcium than any of the other groups. It doesn't matter which animal you use. Fecal calcium, again, soy gave the best retention of calcium, better than casein and better than milk solids. Urea production, turnover of the protein as to what you have to get rid of. Soy was the best, casein and milk solids were the worst. So let's compare soya and milk solids in terms of cholesterol. And my students do this too. Plasma cholesterol levels of rabbits fed in 18% protein rations derived from soy and milk. Cholesterol generally, soya gave low cholesterol, milk solids gave high cholesterol. Now that I would expect. Question: what causes the high cholesterol? Is it the fat in the milk or is it the protein in the milk? So how do you test that? Obviously, we'll say, well, obviously it must be the fat in the milk, but not necessarily. You see, there are always two sides to a story. The fat is the one that will cause the problem, but the protein is the one that carries the fat to where it has to be. So it can be in either. So how do we test that? Well, you take the fat out and you use only the protein. So here's another one. We first looked at bad versus good cholesterol, LDL cholesterol, much better in the soy, supersonically better in the soy than in the milk solids. And HDL cholesterol, that's good cholesterol, when we fed them soy, that was much better than on the milk solids. So the ratio gets better once you start using the plant products. And that's what you want to look at. HDL versus LDL, good versus bad cholesterol. On soy, the ratio was excellent. On milk solids, the ratio was pathetic. Interesting. Now, let's go to the casein. Let's cut out the fat. Cholesterol levels. Soy, low. Casein, high. Now, there's no fat. There's no fat and no added cholesterol. HDL, LDL, casein, poor, soy, good. So now, I had a question earlier. What's better? Skim milk or full cream milk? Let's have a look here. Let's run through this. We did it yesterday, but we'll be a bit more specific. Rabbits on an animal-based protein will have high cholesterol. Rabbits on a plant-based protein will have low cholesterol. And these were the proteins. Do you remember them? Plants and pork and chicken and beef and whole eggs and casein and turkey and skim milk and egg yolk protein. Now have a look here. Plant proteins give you the lowest cholesterol. Then the animal proteins give you high. Casein by itself gives you very high cholesterol levels. Just by itself, without any other fat added. And then we come to skim milk protein. Look at that. It's the second highest cholesterol elevating protein in the world after egg yolk. So now, if they tell you change from full cream to skim milk, will it help, yes or no? Not one iota. Because the problem is not only in the fat, the problem is also in the protein. And because the protein is one of the worst in terms of cholesterol elevation, the best thing to do is never to use this protein at all. So chuck away this product. And which milk should you use? You can use any one that comes from a plant protein. You can use soy milk. You can use rice milk. You can use oat milk. You can use combinations of those. There are nut milks and all kinds of marvelous things that you can make to suit your palate. And you don't have to suffer with these things. Fruits, vegetables, nuts, legumes are good sources of boron, which helps stop calcium loss in the body because milk is low in boron and high in phosphorus and protein. It is not a good osteoporosis-fighting food. Even the journal Nutrition Today says that. Greens, kale, broccoli, and so forth are your best sources. Even when eating 1,400 milligrams of calcium daily, one can lose 4% of his or her bone mass each year while consuming high-protein diets. American Journal of Clinical Nutrition said that years ago already. By the way, 1,400 milligrams per day is a typical US supplemented calcium intake. Guess what Africans in Africa are getting on average in rural areas? Only about 350 milligrams. Only about 350 milligrams. Wow, that's just a fraction of what the typical American is getting and losing 4% of bone mass while on this diet. And the Africans, with just over 300 milligrams per day, lose no bone mass. Where's the problem? The problem lies in the diet, in the difference in the diet. The Africans eat grains and legumes, which are great sources of calcium. They get more calcium from their 350 milligrams than the European gets from his 1,400 milligrams, because they go straight through and urinate them out. And then they still have to release to solve the acid problem from the bone, and they deposit them and they get gout and arthritis, and they walk around like this, and they tell you, you better drink milk too, because you better become as sick as I am. Under controlled conditions, the level of dietary protein has a profound and sustained effect on urinary calcium levels. So the traditional African diet versus the westernized diet. We got heavily into this research, and we wanted to prove that we were not doing the African people a favor when we were taking them out of their rural environment and urbanizing them. By the way, what is the main relief food sent to Africa in times of famine? Milk powder. You know what? I have said this publicly on radio, on television. I've said it all over the world. People just don't get it. You send those poor African kids milk powder, what are you doing to them? They're already emaciated. Now they get a glass of milk, and what happens to them? They get diarrhea and they die like flies. In some areas in Africa, they call it the white man's poison. And some tribes have developed a use for the milk powder. They make a paste out of it, and they paint their huts with it. That's the only thing you can use it for. So we wanted to know what this effect was going to be, and we wanted to simulate the grain and the legume diet, and we used the vervet monkey in order to do this, because this is the only animal that is recognized as an equivalent. What do we find? Maize legume diet versus the milk solids diet. If you look at urine production, again, the milk solids eventually cause a problem. If you look at stool production, they were slightly lactose intolerant, so they are a good model for African people. All animals are lactose intolerant. African people are lactose intolerant, so this was a good model to test it by. Maize legume, milk solids, you would have a problem with the milk solids with stool production. So they would develop slight diarrhea, just like the African people would. Urinary calcium loss on milk was always consistently higher than when they had maize legume. So the osteoporotic diseases would develop in urbanization. About 50,000 Americans die each year of problems related in some way or other to osteoporosis. And dietary protein increases acid production, which can be neutralized by calcium mobilized from the skeleton. That's how you overcome it, and that's why you lose the milk. Now remember the study on milk and infertility, where we said that there was a fall-off in fertility related to galactose in women? So we wanted to test, well, what about the men? So we wanted to know what the effect of this diet would be on sperm, for example. And here's the one that will show you the picture the best. Progressive motility. So we took the sperm of male vervet monkeys that had been fed grain legume diets, that's a typical African diet, and look at the sperm motility compared to those that got milk. Boom. Almost a third. That meant that the sperm of these monkeys was swimming when they were on grain legume, and they were swimming when they got milk solids. When we look at the sperm concentration, this is the one that gives you the best picture again. High concentrations on grain legume, low concentrations on milk solids. So just the diet totally changed the whole sperm parameter. Now you can imagine why European couples, 1 in 4, seek fertility treatment. The women are affected by the galactose, the men are affected by the casein. Just changes the protein parameters and makes for immaturity of the sperm. We delivered this at conferences all over the world, and sperm mid-piece defects when they were on dairy, they also had more abnormal development. Typical defects would be this little bump there or kinks in the tail. So bottom line, guys, if you want to be fertile, kick the milk habit. Your sperm will go, it'll be plentiful, and not like these go around in circles not knowing where to go. Lymphocyte levels. This is very interesting. Maize legume diet, milk diet. Notice that the immune system was far more capable. This is not infectious. This is all within good parameters. But they were far more capable if you were off dairy. So if you want to boost your immune system, then get rid of the milk. Now, African people are lactose intolerant, so they in particular should get rid of the milk. But in the AIDS epidemic, for example, in the world today, if they could kick just the milk, the white blood cell count would rise, and AIDS lowers the white blood cell count. So one of the best ways to counter the immediate effects of AIDS is just to go on a healthier lifestyle. Also, when we looked at HDL, LDL, the parameters were far better on the maize legume than on the milk. And this is the sad state of the blood vessels after a few months. Here's the main artery of one that received maize legume. Perfect. By the way, they didn't only get maize legume. Okay, they got everything else that a monkey eats. It's fruits and everything else. Just a little ball of food, the energy food, was maize legume, a small part of the diet. So they didn't only get that. They had fruits and veggies and everything they wanted to eat as well that monkeys eat. And this is what it looked like. Perfectly squeaky clean blood vessel when they had maize legume. Look at the little side vessels. All the little openings are perfectly open. There's no clogging of the arteries. The same time period, one that got milk. Look at that. All this fat deposit in there. All the arteries partly clogged. This is a terrible situation. And then just to show you the histology, that's a cross-section of one that received maize legume. There's no fat deposition in that blood vessel. It's squeaky clean. Look at this guy. Look at that huge amount of fat deposit over there. That's plaque development. All this over here, plaque development. And look at this. This was a calcium deposition. So it couldn't get rid of all the calcium it had deposited in the blood vessels. So these blood vessels were brittle and they were full of cholesterol. And that's dairy for you. Dairy products are a no-no. Soy milk versus milk solids. Then we wanted to show that soy milk would be the same as giving them the direct the grain and the legume ground up. So we used soy milk powder and we compared it with milk solids and we used the same, and that would be what would be the case. We found milk, of course, implicated in high cholesterol, high LDL, low HDL, and we look at those results, we find exactly the same thing. Cholesterol was high when we had the milk solids and low when we had the soy milk, exactly as in the other one. LDL was high on the milk and lower on the soy, and lymphocyte counts on the traditional, on the soy, in other words, was much better than on the other one. And sperm motility, exactly the same story. When they used dairy, it was low. When they used soy milk, it was higher. And here's your correlation of hip fractures, osteoporosis. Notice, African blacks don't have osteoporosis. If you go up here, the USA, you have osteoporosis. Now, if you continued this graph, it's not on this graph, if you continued this graph up and you went as high as the ceiling over there, then you'd get countries like Norway fitting in to the picture, and Holland and Sweden and Switzerland and countries like that. Relationship between calcium intake and hip fracture, again, look, Norway, way up there. Sweden, way up there. New Zealand, Denmark, United States. So these countries up here are the worst off. Now I ask you, with tears in my eyes, think about this. If dairy is to prevent osteoporosis, why do the dairy countries have the highest rate of osteoporosis in the world? If you can answer me that question, I'll smile. Nobody can answer that question. And the solution in Norway, I lecture in Norway as well, they say to me, don't talk about milk, please don't talk about milk, it's our national diet. I said, you want them to remain sick? They're the worst in the world. They're number one in the hit parade for osteoporosis. And I said, why are you number one in the hit parade for osteoporosis? You have the most milk in the world. And what do the doctors say is the solution to your problem? To drink more milk. Do you want to climb higher in the hit parade? Where do you want to get to? The moon? Give it up and come down to this level, and you won't have these diseases anymore. Osteoporosis costs 6 billion Denmark in that time per year. And the man's cancer? There's a correlation. Milk consumption, just 4 glasses of milk. Just 4 glasses of milk a week will give you 2.5 times the chance of getting prostate cancer to someone who does not do it. So, if you want to know where in the world you will find the highest rate of prostate cancer, you don't have to guess very long. Who are the top 2 countries in the world? Switzerland and Norway. Why? Those are the dairy countries. Those are the dairy countries. Why would you want to subject yourself to that? And now here's the bad news. For African Americans and African people in general, they've had a much shorter historic time of subjection to the Western diet, which means they still have the system that is supposed to cut out these products once they are weaned. So now, if you don't, this is the problem that you have. White males, prostate cancer. These are age-adjusted cancer rates. The figure there, 23.6. Black males in the USA, same disease, look at that, 52. The probability of getting prostate cancer if you are a black American is more than double the probability of a white getting it in this country, simply because of the history of usage of dairy products. So if you're a black person, you should be twice as careful. So obviously we are right when we say to the governments, why do you introduce dairy as a food for urbanized black people? Why do you do that? Why do you not propagate grain legume diets? Why don't you propagate natural foods? You don't. You're going to sit with epidemics like you cannot believe. And they are sitting with them. And do you think they will listen? Absolutely not. Gasping for breath? The number one drug sold in the United States is allergy, and that's everywhere in the world. Here you have Israel Journal of Medical Science. Dairy products may play a major role in the development of allergies, asthma, sleep difficulties, and migraine headaches. So to sum up for you, what's good in that picture? Well, I guess you could eat the roll, but it's refined. So I guess you're stuck with the lettuce and the tomato and the cucumber and this one over here. And if you look at the cheeses, then this one over here would be the least objectionable, although it has the casein, it has the galactose, and it has the oxidized cholesterol, so I wouldn't use it as a food. This one over here is a mature cheese that is more objectionable because it has more oxidized cholesterol. All of the products that are useful are just about gone. It's practically concentrated casein and galactose. And this one over here still has some aromatic bacterial waste in it as well as a special bonus, but you pay more for that. So my suggestion would be to choose a healthier alternative to dairy products. And we will be dealing with that in another lecture. Thank you.